Alright, we're recording, we're good to go. Alright, let's see, where are we? We're done with ODP 306. Any questions on the ODP? Presumably pretty doable. All right. Final questions on PA3. This is an excellent opportunity to talk about PA3 issues. Tomorrow morning will be a horrible opportunity to talk about PA3 issues because I will probably have multiple people all asking for last minute help, and it's pretty much first come, first serve.
So the game is called 20 questions, but is it supposed to end after 20 questions or just keep going?
No, so I noted in here we're not restricting this to 20 questions. So keep going until you get to a leaf node, which sometimes will be much more than 20.
I have a question.
Mm-hmm.
So I created two nodes, the question node and the answer node. These are the two nodes for if the user said no to whether or not they got the answer, I guess, correctly. How do I physically add it to the tree in memory?
So you've got your tree and or your tree, and you're moving down from node to node, and let's say you get your last question, is it furry, and you say yes, and you say okay, it's a dog, and the person says no, it's not a dog. Okay, so I think you said you called this temp, right? And so you change temp to be does it bark? And if yes, then it's a dog, and if no, then it's a cat. And so I think the question is, how do you change this node to be temp, right?
Yeah.
Um.
I think the biggest that would be good too, mainly because I don't want to have to like modify where I'm in the tree.
Right.
And the thing is that the closest I can get is actually setting temp to be the new node. But if I do that, it's going to become the root node, which is not what I wanted.
Right. Right.
So, and that's kind of a challenge. I'm just coming up with this challenge for hours trying to figure out how do I add like a temporary node to somewhere in the tree specifically. And I kept like, because every time I called the petty game again, it didn't update the tree, but rather it would update the tree or as some other tree. It's like as if it was creating a new tree and so on.
Mm-hmm.
So,
Okay. So here's what you can do. We know that there's always at least one level to the tree, right? Because I told you can assume that 20Q has at least, one question and two answer nodes, right? So start off, with temp equal to your root. And let's suppose that the answer to the first question you ask is yes. So you're saying, temp equals temp dot yes, correct?
Yep, that's correct.
All right, so before you do that, have another node, call it previous, and say previous equals temp.
Yeah, I think that's what I just did.
Okay, and then have a Boolean or something, some kind of variable called direction, and set that equal to, I don't know, 1. 1 equals yes, 2 equals no. What we're trying to do here is when you move down to another node, so we come down here, you want to remember two pieces of information. What was the previous node, and which direction did you move to get to your current node?
This is way more complicated than the way I did it.
Can I hear the way you did it?
I created two subnodes of whatever current node I was. So I was on some answer node, and I said the answer. It wasn't the correct answer, so I took user input created a new sub node, and then made new sub no node and made that my current node, and then replaced the text in the current node with the user's new question. So I didn't have to remember the previous question. I just replaced the current answer node with the new question node and created two sub nodes.
Right. So if
I think that's what I did, but the problem is that I was not able to figure out what to actually add to the tree. That's like the biggest downside.
So if you have a variable that's actually pointing to this node, you can just replace the text, the yes and no child of it. The trick is that depending on how you're writing your code, what you may actually have is a copy of this node. And if you change the text and the yes and no children in a copy of this node, it doesn't change your tree. So if you actually have a reference to this node itself, right, you can just update the fields of that node. But there are ways you might be moving through the tree where what you end up with is actually a duplicate of this node, and changing the duplicate doesn't change your tree. So your other option is to keep track of how you're moving through your tree, right? And it's more complicated, but it's really two extra statements, right? Before you move to a new node, remember what your current node is, call that previous. Remember which direction you went. And so now, you know, this is temp, this is previous, and direction is yes. And the answer to this is no, so now this is temp, and this is previous, and direction is no. And you ask, is it furry? And they say yes. And so you come down here, and this is temp, and this is previous, and your direction is yes. And this is an answer node. You say, is it a dog? No. Okay, tell me a question. Does it bark? Yes is dog, no is cat. Well, now all you have to do is say previous yes equals, and you can set it equal to whatever this new node is that you create.
I wonder what I did, because it works for me. I didn't create a duplicate. It just adds it to the tree. So I don't think I did anything special.
So when I wrote this up myself, right, I did it like this. And then when I was describing it last week, I was thinking, this probably isn't necessary. You should be able to just do what you've said you've done, right? But for some reason, when I first wrote this, I did not do that. And I think I may have stumbled across a way of going through the tree where something happened similar to what seems to be happening for some other students. But I'm going to go back and change my code and try to do it this way with just changing the fields in that node. And it seems like it should work. But like I say, I didn't do that when I first wrote this up. And there might have been a reason for that.
Question I have, also relating to nodes,
Mm-hmm.
is how to set up, like so I have a node class and like node.java and tree.java.
Okay.
But in my node class, I'm just wondering what the how I'm supposed to set up the constructor so that it basically does the same thing as if I were to make a node like structure like in C.
So you don't even necessarily need a constructor. Constructors are kind of a convenience thing.
No,
I mean
for like creating a new node, like when you're like ingesting, you know.
right. Well, ingesting is different, right? So for the node class itself, right, you can just make a class node. With some text and a boolean to tell you if it's a question or an answer, and a node yes and a node no. And that could be your entire class, right? With a default constructor, or you can have some methods for interacting with this, but nothing directly to do with ingesting. If the question is how to ingest, right, that's a method that will possibly be a part of your node class, and it's this recursive algorithm, right? But is that what you're asking about?
No, I just haven't tested mine yet.
Okay.
And that's probably, I know that's a bad thing. But I just can't help but get the feeling that that I'm probably like, because mine is like, I don't know. I don't have a good feeling of how mine's gonna turn out.
Sure. Yeah, and that's okay, right? This is a bit of an unusual assignment because I've given you an ingest algorithm that I've told you will work, but we haven't really spent a lot of time digging into why that algorithm works, right? And the reason for that is that that's not really my goal in this assignment, is to be able to understand that recursive algorithm. I really just want you to get into the objects of building a larger Java program. And so I'm giving you that algorithm as kind of a, this will work, just do it like this. But if you don't understand why it works, right, it's
No, I do.
you do. Okay, good.
I do. It's just
Yeah, so start testing then, right? There's a very good chance your code's going to work better than you think it might, right? Because I've seen you do this before, where it's not clear if this is right, but it turns out it's exactly right, or it's really close to right.
So I have a question.
Yeah.
So when I say node temp equals root on the very beginning of the play game method,
Okay.
is it actually copying the contents of the tree into the node, or is it like kind of creating a pointer? I'm kind of lost on what I'm actually doing with temp.
So let's try this. And this is going to take us into something that will also affect us in PA 4 and 5. So let's look at copying nodes and so on. All right, so let's just play with our rectangle class, right? So this is just our plain old rectangles, and let's make a main class, and let's see what happens. So I'm going to make a rectangle called original. That's going to be a 5 by 7. I'm going to make a new rectangle named copy. And I'm going to say copy equals original.
If you change original, will it change copy?
That's the question.
Yeah, so it doesn't.
And if I change a copy, will I change the original?
My assumption would be no, but I don't know 100%. I don't know 100%.
This is a huge problem with JavaScript. It does that.
Well, I'm pretty sure that copy and original are reference variables pointing to the same object.
Mm-hmm.
Right.
So let's see. We know our original is going to be 5 by 7. We're making a copy. We're going to change the dimensions of the copy. Let's see what the original of the copy are after this madness transpires. after the typos go away. All right. So our copy changed when we changed the original. So when we say copy equals original, it's not actually creating a new version of it. It's making a second reference to the same object. So we can think of it like pointers.
What I just looked up is that when you're dealing with primitives, it does create a copy.
Mm-hmm. So primitives, you get a copy, but for an object, you just get a reference to the same thing.
Is there a way to dereference those?
So, let's try this. We're not going to try that. All right, forget that. So you can certainly make your own copy method, which would create a new rectangle and then copy the height and the width into it. And then, you know, you'd have a completely new node. But by default, I don't believe there's a way around that. And let's just close the loop on this.
So in this case, if I were to do like node temp equals root, then temp would be basically pointing to root instead of actually creating a copy, correct?
Yes. And so whatever you do to temp would happen to root, which in this case is probably the thing we want. Right, so here we just tried the other direction. We made copy equal to original. We changed original and our copy changed. So it's absolutely, you know, two things pointing to the same object. So yeah, that suggests that if you're moving through the tree and you're saying, you know, temp equals temp.yes, and you ask the question and it's wrong, in the end you should be able to say temp.question equals does it bark, temp.yes is this, temp.no is that, and it should patch up your tree perfectly. And this gets into a bigger area, right? So if we set, you know, some object equal to another object, it gives us a reference to that first object. Sometimes. So eventually we'll talk about a notion called deep copy versus a shallow copy, and this will kick in when we have, you know, a structure that contains other structures that contain other structures, and you make a copy of that top level structure. How much of the lower level structures get copied? So if everything gets copied, that's called a deep copy. If just sort of the top levels get copied, that's a shallow copy. But let's just make this even more interesting. So let's try this with strings, right? Set our old equal to hello, set new equal to old, and then we'll change, let's change old to haha, and see what happens to new. Ooh. Oh, I can't do that. I am temporarily losing my brain. Why can't I say string new? My bad. New is a keyword.
Oh, because new kind of represented like a new class.
Yeah.
Or something like that. Yeah.
Yeah.
That was throwing me off too.
Well, that was.
I think the benefit about having color text is that new would be highlighted as like an orange color.
That's true.
So you probably would know what you know.
Yeah, that would have been nice. All right. So here I had an old string hello. I set newer equal to old, and then I changed old to be haha. But my newer string is still hello. So what's happening with strings here is different from what happened with the rectangle, right? And that's fun. Strings are not primitives, they're a class. So I don't know if there's a consistent explanation for why this happens with strings and this happens with rectangles. But that's what happens. Let's see.
I'm just looking it up, and it says whenever you create a new object using the new keyword, it creates a space in the heap memory, and then the reference variable points that space in the heap. I wonder how Java is handling the creation of space in memory for strings.
So I think the trick is that I don't have to say old equals new string parentheses hello, but I think that's what's happening. When you have a string, there's kind of an implicit construction that takes place. I don't know this for sure. This gets into kind of the sausage factory part of Java, I think. But you know, clearly this is different from a rectangle because I never say new string, but certainly you know something is calling the constructor for a string, and I think that's why this is acting differently. But for nodes, for trees and so on, right? You can believe that the equal sign gives you another reference to the same object as opposed to constructing a new object. But strings might be an edge case. So I don't believe there's a node class built into Java. If there is, you should not use it for this, but you really don't want to use it for this. Because you need to do this, you know, funny node left right ingestion and so on. But if you're struggling on this, definitely office hours, right? And slip days and so on.
So just, if I wanted to just do a constructor for when declaring a new node, then I just don't understand what I have to do that's different. That's like that's different compared to C, but does the same thing as a structure in C.
So if you said public node,
Yeah.
right? That's the declaration of a constructor.
Yeah, I just don't know what to put inside. I
I'm not sure you need anything in there. I'm not sure you need a particular constructor. So let's say you're doing something with your tree. Let's say you're ingesting your tree and you need to create a new node, right? So you read the first line of your file and it's an answer node. So we've said if it's an answer, set the text to the text of the answer, set your Boolean flag to false maybe, set the yes and no children to null. So you would do something like this, you know, node temp equals new node. And then you could say temp dot text equals, you know, maybe the next line from your scanner. So you read your scanner and you found an A colon. So you know that this is an answer. So call the next line that gives you a string. Set your text field. Temp.QFlag equals false. And then temp.yes equals temp.no equals null. And if you're going to do that, you don't even need to define a constructor. There's a default constructor that will allocate memory and make space for these four things when you say new node, but then you're going to go ahead and you're going to set the fields, you know, to the exact values you want, so you don't even need to define a constructor. But sometimes, you know, you might make a constructor that lets you specify the text and the flag and the yes and no children. Then I could just say new node parentheses, you know, sc.next line, comma false, comma null, comma null.
Yeah, that's what I did. It made the main program look a little cleaner.
Yeah, yeah. So you can do things like that. They're kind of conveniences or ways to streamline the code. But all you need is to, you know, say this is a new node. You don't need to write a constructor for that because you can always use the default constructor for any class you make and then set up the fields however you want them set up. If it's an answer node, right, the only difference would be, you know, make a new node, set the text equal to the next line, set the question flag to be true, and then you could say temp.yes equals ingest, parentheses, you know, sc or your scanner object, and then temp.no equals ingest. And those two statements would make a recursive call to the function that this is sitting in and suck in those parts of the file.
Okay. Okay.
And start with a simple file. Start with that three node 6-line file. And if you get that working, you're most of the way there actually.
Okay.
Cool.
I have a question.
Yeah.
So I'm looking at my code right now, and to make my code cleaner, could I create a function or a method inside the tree class that takes the previous and the current nodes and kind of arranges it accordingly, and then pass back the node? Or
What do you? It depends what you mean by arranges them appropriately.
For the new question answer node that I was talking about beginning of the class.
Oh, so for setting this up?
Like modifying the tree.
Yeah.
Yeah, but yeah, create a method inside the tree class that does all this, and then goes and then continues playing the game. Instead of having to put all the instead of putting all the new nodes and a bunch of like node manipulation inside the play game function.
You could. You have to wire it up just right. And I don't think this is a lot of code. If you wanted to modularize, you could have a method that I was going to say you could have a method that, you know, does the interaction with the user, give me a question, give me the thing you were thinking of, and maybe returns, you know, these nodes and this node or something like that. But for the sake of getting it working, I would err on the side of just doing it all inside the play game method. And once that's working and you've got a tar file and you've got it submitted and you're good for 100%, then you could go back and think about, well, how could I have put this into a separate function? My hesitation is because in the past with assignments like this, I've seen students get kind of stuck trying to do too many things like that. trying to have something that, you know, I can tell it what this node is, and it will go ahead and update the tree for me, or you know, things along those lines. I mean, it's okay if your play game method is 20 lines long. That's not, you know, a ridiculously long single method. And, you know, playing the game is a while loop with 3 or 4 statements inside, and then the rest of it would just be, you know, this fix up business. I think it's great to have play game be a separate method, so your main program could just, you know, keep playing the game in a loop, or, you know, have a way to exit or something. But I would tend to say, you know, for first cut, try fixing up the tree inside the play game method. And then at the end of that, you know, before you're done playing the game, if you updated the tree, go ahead and maybe call another method to do the writing of the file. So call your node left right traversal, open a print writer and write the tree out. Do that in a separate piece of code.
Yeah, I think I'm putting the right the what's it called, the print writer.
Mm-hmm.
What was it called?
Yeah.
I tried to put that into a different method so that way I did tree. I'm always a big fan of like organizing work.
Yeah, cool.
But the problem is that when I try to organize work to be fancy about it, sometimes it just doesn't work.
Right.
Especially if I'm passing values in and it's not like actually doing what I expected to do.
Yeah.
So for the print writer, when you create a print writer, are you rewriting the entire file? And if so, how would you do it?
So you've got a method called you know, rewrite file. So rewrite file. Give it a file name, give it the root of the tree maybe, right? Or, you know, if you're doing this in the tree class where you've already got the root, maybe you don't need the root. But, you know, some sort of method like this. So open, you know, print writer. And then root dot node left right. You know, let's say that your print writer is called pw. So if you put a traversal method in your node class, right, root is a node, call that thing's traverse method, pass it the print writer. And in the node class, what do? Well, pw.println. Figure out if the node's a question or an answer and print either a Q or an A into the print writer. And then print line whatever the text is. And if it's an answer node, you're done, because you have no children, so you don't have to do anything on the left and the right. If you're a question node, then do left dot node left right print writer. So if it's a question, call the left subtrees node left right, and then call the right, or I broke my own rule. Call the yes nodes node left right, and then call the node nodes node left right. So that's your 4-step traversal algorithm. And it's 4 steps instead of 3 because you have to print 2 lines. So print out the text along with the tag for question or answer, and if it's a question node, recursively print out everything in the yes tree and print out everything in the no tree.
So it's kind of like similar to reading the tree in the first place.
Exactly.
It's that you're kind of traversing it.
Mm-hmm.
I'm at the right and left, no left and right method to do this.
Mm-hmm. Yeah, but it's a 4-line method. So a lot of the question with the stuff we're doing now of how to modularize will often be based on recursion. right? When we have some behavior that we want, and that behavior is going to be implemented using recursion, we're definitely going to need to farm that off into a separate method, right? Or a pair of methods or something. And so this, I can't put that at the bottom of the play game method after I touch up the tree. I can't recursively call play game, right? I'm going to need a separate method, which will basically be, something that will start this recursion on the root of my tree. And so sometimes that's how we drive our decisions about what to modularize, is what needs to be a recursive function. All right, good. Other questions?
What would you say is a healthy length for the play game method? You said it's okay if it's 20 lines. Mine's more like 50.
I pulled 20 out of the top of my head. Yeah, 50 does not sound unreasonable. I mean, because you need some user interaction, and especially at the end of the game, you have to say, here's the answer, and you have to find out if that's right. And if it's not right, you need some back and forth with the user to get the correct information. So I don't think 50 is unreasonable at all. But this part for recursively writing the node, if this got up to be 50 lines of code, you're probably doing something different from what we're thinking of here, right? Because most of these recursive things should be pretty short, right? Maybe check some edge in the beginning and then do your recursion and maybe do something at the end. But the gameplay is a non-recursive part. It's usually going to sit inside a loop. And so that's going to be a little longer.
I do have a question.
Yeah.
I thought of. So, when do you want to update the file? Do you want to, every time the user enters new information, do you want the file to be updated right there?
Mm-hmm.
Or only when the user ends the game?
So I didn't really specify in here how the game ends, right? And in the sample code, the game never ends. It just keeps going back and playing again and again and again. So definitely update the file as soon as the tree gets updated. Particularly if there's no way to exit the game, right? The person's going to Control C, and you don't want those updates to get lost. So I'll go ahead and tag that in the video. Update the file as soon as the tree is updated. And then after playing, when it starts playing a second time, if I want to Control C out of the program, that's okay. The file's already been changed. Make sure you close your print writer when you're done writing the file. Right? Otherwise, you can write a bunch of stuff into the print writer. If you don't close it, two things happen. One, your changes don't get written to disk. Two, if you try to open a print writer a second time to update the file again, you might get into some weird issues if the file's already open. Yeah.
Maybe we went over it, but when we print this in, we're not just adding it to the end of the file, right? We're adding it to a specific spot in the file.
No, you're creating the entire file from start to finish.
Oh, okay.
Yeah.
Right, now I remember. Right, okay. I forgot about that.
Yeah, that's a biggie.
I mean, that would be hard, wouldn't it?
What would be hard?
Adding to the end of the file instead of rewriting the entire file?
It would be hard and probably incorrect. So rewrite the entire file each time. The worst thing to try to do is update the file sort of, tactically. Go through the file and say, oh, in between here and here I should add, 6 more lines. That's a nightmare, right? So we're just going to blow away the whole file and just rewrite it from beginning to end each time that we update the tree. And if you were doing this, in a production system, maybe you would do something like, before you do that, you'd make a temporary copy of the current file. So you'd copy 20q.txt to 20q.txt with a tilde at the end. And then you'd go ahead and blow away 20q.txt and recreate it. The reason for that is, if something happened partway through the writing process, if the machine crashed, right, potentially your database is destroyed. So we make a copy of it first, and then we start rewriting this new file. Well, if we get halfway through and our system crashes, and we reboot and we only see half of our database file here, we can go back and find, this temporary file and say, oh, there's the version before it was updated, and you can recover. And so a lot of programs that you run, while the program is running, you'll see temporary versions. Sometimes they're hidden files, sometimes they just have tildes or underscores. That's part of what's going on, right? It's a way to manage recovery if something goes wrong while something's being written. Because a lot of these things, I mean, when you're in a word processor and you people don't use that word anymore, but someone used it this morning. When you're in a word processor and you've changed your document and you say save it, right? It doesn't just go into your file and add a boldface in front of a word. It rewrites the entire file from start to finish, right? It feels kind of heavy-handed, but that's usually what these kinds of programs do.
I'm kind of makes me want to think that it would be a lot more efficient, efficient time-wise to only add to the file instead of rewriting the entire file. Just wouldn't that take a lot longer for like really big files?
Yeah, but we got really fast machines. So it can definitely get to be an issue for very large files, and for something really large, like if we're dealing with a terabyte file, then it may be worth actually trying to go in and manipulate the middle of the file. But you would probably design your file in a way that things did not have to be sequential. So if I wanted to add something in between these two lines, I wouldn't have to move everything down, and so we'd have a more complex file structure. And that's one reason why typically, if you look at an old Excel spreadsheet and you look at the actual XLS file, it's not just, a series of lines showing you the contents of each cell. It's got some sort of data structure or multiple data structures associated with it that would let you, perhaps do things like have things in the file out of order and so on and so forth. But fortunately, 2022, we have 3 gigahertz machines. We have multi-terabyte hard drives. We have 16 gig of main memory. We can be kind of sloppy in ways that we couldn't have been, say, in the 60s when we had 16K of memory and no hard drives, or paper tape. So
Back when programmers were programmers.
when programmers were programmers, man.
One question.
Yeah.
I don't mean to interrupt that.
No, go for it.
Anyway, one question I just thought of. I remember when we did a similar assignment to this in 222. I think it was PA4.
Okay.
We had the tree free method.
Mm-hmm.
You need a separate one for this.
No, you don't, because Java takes care of that for us. So every time that we abandon a piece of memory, an object, and we don't use it anymore, something in the Java machine will eventually notice that and reclaim the memory. So we're completely absolved from managing memory leaks and stuff like that once we're using Java, which is kind of nice. And in fact, it's recommended that we don't manage memory on our own. I've had a few students turn in code where they'll do things like delete nodes from a linked list at the end of their program. It's actually it's pretty efficient to just abandon the nodes and let the Java garbage collector gather those up for you. So that's kind of fun. All right, good. What else?
Okay. Give me 30 seconds.
Okay. Well, let's go ahead and take a break, and we'll come back in about 5 minutes. And if anyone has come up with more questions after break, we'll keep talking about those. And then when we're done with questions on PA3 or other things, we'll go ahead and we'll take a look at PA4, and then we'll hop back into Eclipse and talk some more about making GUIs and graphical interfaces. So let's
We don't really need Eclipse very much versus PA3, huh?
don't need a what?
We don't really need Eclipse.
No, PA3 I was suggesting still do it on the command line.
Okay.
Yeah. All right, cool. I'll be back in a few minutes.
Hey Nick, you're there, right?
Yeah, I'm still here.
Okay, just real quick, actually no, I'll let you answer it when we're all back, but like, how do we detect whether or not how do we detect if a database file does not exist?
When you try to open a scanner on it, you want to do that inside a try-catch block. And if the if any exception occurs, if you end up in the catch block, database file does not exist, just print a message and exit, you're done.
That exiting is just return 0 or something, or just return?
Yeah, just return, because you're in a public void main, so just a return statement will get you out of there.
Gotcha.
Yeah.
You can also do file.exist.
Mm-hmm.
But that's the thing.
Yeah, there's-
Like, you have to like make a file object, right? A new file, and then you just do if file.exists.
Yeah, there's a ton of methods in file that are pretty slick.
Hmm.
You can also check like directories, or if it's a directory or a file, or all sorts of different stuff. It's pretty neat.
I prefer the hope and pray method.
Yeah.
All right. So other questions?
Wait.
Mm-hmm.
For the case in which we're running the main with a file name other than like if it's just Java PA3 and then file name.
Mm-hmm.
How do we get that file name from the scanner?
So assuming you're doing public static void main string bracket bracket args.length, no parentheses, tells you how many things are on the command line argument.
Yeah.
So if args.length is equal to 0, you want to just go with 20q.txt from your current directory. If this is equal to 1, then you want to use whatever is inside args bracket 0. And so when you construct your scanner, you'd say new scanner parentheses new file parentheses args bracket 0 instead of 20q.txt.
Okay.
And then again, if you're constructing your scanner, you're forced to do that inside a try-catch block. And if the file doesn't exist or you don't have permission for it or something, you'll throw an exception and you can just say, you know, can't open that file, goodbye, and you're done.
Oh yeah, good question. I never remembered. I
Mhm.
never remember that either.
You did or didn't? Okay.
I didn't remember to ask, really.
Okay.
If you would make that one, John.
Yeah. So exactly the same way as a makefile in C, but your dependencies are .java files, and your recipes would be things like Java C. So I could say, you know, my executable would be pw.close, and it depends on you know, tree.class and node.class and pa3.java maybe. That looks a little weird. But then my way to build this would be Java C pa3.java. So what is this first pair of lines in my make file saying, you know, the main thing I want to come away with when I say make is pw.3.class. That's kind of like our executable file, but it's our main class file. And for this to be up to date, I need tree.class to be up to date and node.class to be up to date, and I need, you know, pa3.java. So if pa3.java changes, right, it will say, hey, I need to rebuild the class file. If node.class changes or tree.class changes, I don't really need to rebuild the class file, but it will force that to happen. And then, you know, tree.class depends on tree.java. And the way I compile this is I say java c tree.java and so on.
Okay.
And most of the time, if you just have, you know, everything in one directory, and pa3 calls trees and trees construct nodes, right? If I just recompile pa3.java, it'll usually recompile the other pieces as well. If none of my class files exist, if all I have is tree.java, node.java, pa3.java, and I just say compile pa3.java, it will definitely recompile the tree and the node files also. And in your tar file, you're just putting in your .java files. So when I untar and I say compile pa3.java, it should just automatically recompile the other pieces. Where it gets a little weird is if, you know, I change my node class and I try to recompile pa3.java, will it notice and recompile my my node.java? Probably not. So makefile can be useful while you're developing, if you don't want to recompile all your Java files every time. More often than not, when I'm doing Java development, I just make a script called, you know, comp, and it just Java C's each of my .java files.
Wait, isn't the executable supposed to just be pa3 instead of pa3.class?
Your main class is called pa3, which means that you'll have a pa3.class file. But we don't execute pa3. We say Java pa3, which means look for a pa3.class.
Do we need the pa3.java in the first line though then?
Up here, I put that in because if I don't and I change pa3.java and I say make, it's just going to say, well, these two things are up to date. This must be up to date also.
Would it be a good idea then to do that for the tree.java and like for like the other .java files that you have that you might or might not have in your in one's directory or what?
So to make it, this is kind of a goofy make file, but to make a tree.class, really all I need to know is that tree.java is up to date. If this changes, I need to rebuild tree.class, right? And I do that by compiling tree.java. The reason I have these class files up here is because if I change tree.java, right, I want to force my makefile to rebuild my tree.class. And that's not going to happen unless I say pa3.class depends on tree.class. So it's kind of a backhanded way of getting our makefile to do what we want it to do. But like I say, it works. All right, anything else? So let's talk about PA4. So let me pull this up. Give me one sec. All right, so PA4. This is going to be a chance to develop a game. So this is a game called Dots. It's got other names. When I was a kid, we called it Dots. But you may know it by a different name. Let me show you how this game is played. You have two people. You have a sheet of paper and some sort of, understanding about how big the game field is. So I will do this with just a 4x4 grid of dots. And two people play this and you take turns. Alright, so we'll have one person play with a pen and one person play with a pencil, so you can tell whose turn it is. So I'm going to go first. You draw a line, and to draw a line, you connect any two dots either horizontally or vertically. You can't connect diagonally. So I might draw a line like this. And then the other player might draw a line here. And I'll draw a line. It's what?
The square game.
The square game. So you take turns connecting dots together. And if at some point somebody is able to connect a pair of dots and that creates a box, they get to claim that box. And so this is Zog, so Zog puts their initial in there. And if you complete a box, you get to go again. So Zog will draw this line here. And now I'm going to say, oh, I'm going to draw this line here. Hey, I completed a box, I get to go again. I'm going to draw this line. I completed a box, I get to go again. I'll draw this line. And now Zog draws this line, completes the box, and draws this line. And you keep going until all the boxes have been created, and whoever has the most boxes wins. And you may have something like this. And if it's my turn, I might complete this line and I get two boxes. Because, hey, I just completed this box and this box. And then I'd go again, so I'd go down here. And then maybe Zog goes here. And I'll complete that box and claim it. And I'll complete that box and claim it. And I'll draw this line. And then Zog will go here. And so we're done. And Zog got a total of 3 boxes. And Nick got a total of 6, so I won. Alright, so that's the game of dots. And your goal in this assignment is to write a program so that 2 people can play dots on the computer. And you're not having the computer be one of the players, so there's no AI involved here. There's no, logic where the computer's deciding what's the best place to draw a line. The computer program you're writing is just, a piece of paper and a pencil and a way for 2 people to play this game on a laptop by using a computer. And so you're going to do this in Java, obviously. Go ahead.
Oh, sorry, I was laughing.
Mm.
I like the opening.
Yes, yeah. This is a famous game. It may be an Olympic sport someday, and so this will be very valuable to you in your portfolio. So you're going to use Java. You're going to use Swing. You're going to do this in Eclipse. Ideally using Window Builder to help you with the Swing development. And this is really a good exercise in object-oriented design. Because there's going to be lots of classes involved here. The underlying gameplay is pretty simple, right? Draw some lines, see if all 4 edges of a box are filled. If it is, add the current player's initial to the middle of the box. Otherwise, switch turns to the other player. If all boxes are filled, the game's over. See how many boxes each player has. Figure out who won. That's easy to describe in words, but getting that to happen inside a computer program can be very difficult, right? Until you figure out how to set this up. Once you know how to set it up, it's fun to do. I don't mean that, sarcastically. It is fun to do. And it's not a whole lot of code for what you get out in the end. Alright, so work in Eclipse. When you're done, your code should work as a standalone set of Java classes. So you should be able to put your code on a Java machine and just say Java PA4, and it will go ahead and run and do all the graphical pieces and so on and so forth. And this is the first part of a two-part assignment. PA5 will be the same thing, except in PA5 you'll be able to have two people on different machines, and we'll have a network connection between the two machines so that they can both play remotely one game of dots. So I'll see my screen, the other player will see their screen. If I click my mouse right here to draw this line, a line will appear on the other player's screen. And on both of our screens it'll say, okay, now it's Zog's turn, and nothing will happen until the other player clicks their mouse somewhere, and then a line will appear on both of our screens and so on.
So this is going to be two-player, or like how is it going to work on separate screens?
So you have one person on each laptop, right? But your moves are mirrored across the two screens. So when I draw a line, I'll see that line drawn on mine. Say again?
We have to do that on this one or no?
No, it's PA5.
Oh, PA5.
Yeah, that'll be PA5.
Is that like network request?
Mm-hmm.
Oh, wow.
Yeah. So PA4, you want to not just get it done and get a good grade on it, but you want to make sure you understand it, because then we're going to extend it to add this networking component. And if PA4 is in the bag, if you've done it and you understand it and you feel good about it, then PA5 is just adding a network component to PA4, which is totally doable in a couple of weeks. So it's almost like this is a double point assignment, because if you don't get PA4 to work well, then PA5 is almost impossible to finish. But that's really fun when you get this working in the networked version, and you can open up a network connection to your friend's machine and you can play dots online. And then you're doing what you do with any of these multiplayer online games, right? A much simpler game, obviously, but the same ideas. And so that's a really cool target for the end of CSE223. So we'll get to that one in 2 weeks. Yeah.
Is this a group project or is this an individual project?
Good question. This is a group project.
Hooray.
Yay.
Oh.
All right, so it's up to you. If you want to work alone, you can totally do that. But if you want to work in a group, right, you can be in a group of up to 3 people. No more than 3 people per group, though. All right, so let me go through this part first. So the game of dots is played by 2 people. Your initial grid's going to be 9 by 9 dots, so representing 64 boxes, right? And the way that you play the game is you basically move your mouse between 2 dots and you click. And that says I want to draw a line between these 2 dots. The game will automatically know if a box has been completed, and if it has, it will fill in that player's initial, and it will remain that player's turn. meaning if the next click completes a box, that same player gets their initial in there, and so on. All right, and most popular sport in several countries, not really, but you know. All right, so group project, yeah, so groups of up to 3 people if you like. I strongly recommend that each person develop the entire program from start to finish and make sure you understand the entire program from start to finish. And for the group element, right, instead of saying, hey, you work on the graphics part and I'm going to work on the mouse clicking part, and this other person is going to work on cleaning up the code and adding comments, right? That's not a good way to break this problem out. Because when you get to the exam, the questions related to this project will not be, you know, done in a group. They'll be done by you. So if I ask you a question about how to wire up a mouse interaction or how to draw a graphical element, right, you're going to need to understand that part of it. And so even if you've got other people working on this project with you, you want to make sure that each of you understands the whole project from start to finish. And so what's the benefit of working in a group? Well, you can legally share your code with your group members. You can ask questions, you can try things, you can say, how did you get the mouse to figure out where the nearest line was? And they can show you their code, or they can try to help you, you know, figure it out. Or you know, if they're mean, they can say, I'm not going to tell you. But you know, you have this freedom to develop your code with, you know, up to 2 other people, which means you can share code, you can copy code, you can do whatever you want, right? It's all legal. But use that to your advantage to help you understand how to develop the entire program, how to make the entire program work. And so you've got, you know, if you were to start today, you would have 2.5 weeks. I'm assuming PA3 will take people through Friday, so then you have basically 2 full weeks to work on PA4. So, you know, spend some of that time thinking about it, maybe talk with other people in your group up front, think about how you're going to structure it and so on. And then I would say spend some time individually, you know, a day or 2 trying to write this yourself. And if you get stuck, you know, talk to your group members, get some ideas and so on, but make it, you know, 3 people working on the same project, but in a way that lets them, you know, help each other out. And then at the end, you know, maybe decide, you know, well, you know, I didn't quite get mine to work, and somebody else is like, well, I got mine to work, you know, really well except for this one piece, and maybe, you know, somewhere in that second week you'll say, okay, we're going to take this person's version, that's what we're going to turn in. And you'll all work on polishing that up, and then that gets submitted. So along those lines, right, only one person from your group should submit their tar file to Canvas, not Top Canvas. If there's multiple submissions, I'll grade whichever one I come across first, probably the first one alphabetically. So if you got 3 people in your group, make sure only one person submits the tar file, and that is the tar file that everybody wants graded. If you've got, you know, a halfway working program and you submit that to Canvas, that might be the one I end up grading, right? So coordinate this among everybody. And the other thing is, make absolutely certain that in the very beginning of every .java file, I see every group member's full name, first name, last name, right? Because that's what's going to tell me who gets credit for this, because I don't want a Canvas submission from everybody in the group. So make sure you've got names in the files.
Wait, why do you want to have an every Java file? Don't you want it in the main file, like PA4 file?
No, I want it in every Java file. Same way I want your name in every Java file that you make for PA3.
Okay.
Alright, so what does it do? It begins by drawing a grid of dots. So when you first run the program, you should see, you know, 9x9 array of dots representing 8x8 boxes. Make each box 50 by 50. I suggest using variables for these numbers, right? For 8 and 9 and 50, make, you know, box width, box height. Set those equal to 50. It will make your life a little easier. If you start having too many random numbers sitting around in your code, it's going to get confusing, right? If you call this box height and box width, it's going to make a lot of sense to say, you know, take the row number times the box width. And that gives me my x coordinate. Instead of just, you know, 50 times x. So that's a suggestion. So in the beginning of the game, there should be text fields where the two players can enter their names. Remember, this is on one computer, so you're both sharing the screen and the mouse and the keyboard. So there's a text box for player 1, person can type their name in there. There's a box for player 2, person can type their name in there. And then there's a start button. When you click the start button, the game begins. Alright, so it should keep track of whose turn it is. It begins with player 1. And, you know, every time that you click the mouse, the program should figure out which line are you trying to draw. And this is going to take some discussion. But, you know, here's a grid of dots. Well, if I clicked right here, it's pretty clear I'm trying to draw this line. If I click over here, it's pretty clear I'm trying to draw this line. In fact, if I click here, or here, or here, or here, or here, it's all pretty clear I'm trying to draw this line. But how do you tell a computer that? What is it in your code that's going to take the XY coordinates of a mouse click and say, hey, I should draw a vertical line between this dot and this dot? So we'll talk about algorithms for doing that. And there's you know, some potential ambiguity. If I click right here, am I trying to draw this line or that line? Well, I don't know. And what do you want to do about that? Do you want to require that the person clicks, you know, in an unambiguous way, where this means that line, and this means that line, right? So a lot of the design decisions are up to you. All right, and we'll talk about algorithms for this. All right.
So, question?
Mm-hmm.
Is there a feature or function in Eclipse to have you drag a point to one to another, or
To have you do what?
Can I drag a line to the point? If that makes sense.
There are methods we can use to draw lines, and we'll talk about those. Those are methods in something called the graphics class. And so when you click the mouse, we saw the other day, we can capture those XY coordinates, and then you'll write some logic in your code which will say, oh, okay, we should draw a line between this XY point and that XY point. And then there's a method called drawLine that we can call, give it these coordinates, and it will make a line appear. Alright, so clicking the mouse inside the grid area should draw the closest line, unless the line is already drawn. If there's already a line drawn here and the user tries to click right here, that's not a legal move. They can't take that line, it's already taken. So don't do anything. Maybe you could put up a message saying, you know, that line is taken, but mostly you're not going to do anything. You're not going to change the turn, right? You're just going to wait for them to make a legal click and then draw the line. Alright, the game should notice if a box or multiple boxes gets completed from a move that was just made, and if so, it should put the current user's initial into those boxes and keep it as that player's turn. If the click did not create a new box, now you've switched to the other player's turn. The game should continually report the score, so there should be something like a label that says, you know, player 1 score, player 2 score, and those should be updated as boxes get completed. When all the boxes have been completed, the game should notice that and should say game over and should say who is the winner. Or, you know, tell you if there was a tie. And then there should be a restart button, which you can use the start button if you want, just change it to restart. that will completely reset the game and start over again. And you can do that at the end of the game, or you can do it partway through. If you're like, you're going to win, let's start over, you can just go ahead and hit the restart button and begin from the beginning. So here's a sample version of this. So here's my version of a dots game. So I'm gonna go ahead with player 1 is Nick and player 2 is Zog, and I'll hit the start button. And at this point, you know, I can't change my names; those have been grayed out. I've got a restart button. Current score: Nick has 0, Zog has 0, and it's currently player Nick's turn. So I'll draw a line here. Now it's player Z's turn, so maybe they'll go there, and then Nick can go here, and Zog will go there, and maybe Nick goes here, and maybe Zog goes there. And so I'm going to click this line, complete a box. It'll draw my initial in the box. It bumps my score up to 1, and it says it's still Nick's turn. So I'll go here, and Zog will go here, because Zog's not very good at playing dots. And now I'm going to complete this line, and that should give me 2 more boxes. So they both get my initial, my score goes up to 3, and it's Nick's turn again. So I'll go there, and Zog goes there, and Nick goes here. And Zog gets a box finally, and gets to go again, and gets another box, and comes down here, and Nick gets to go, and so on. All right? So that's basically what your PA4 will do, this kind of thing. And you know, if you use variables for these magic numbers, like an 8x8 board and 50x50 pixels and so on, it makes it really easy. You know, if you have something called board size that you initialize to 8, it makes it easy while you're developing this to change board size to 4. You know, and then play a 4x4 game of dots, or a 2x2. Which would let you find out, you know, what happens after the last box is filled. Does it correctly tell me the game is over? Does it tell me who won, and so on and so forth? Bye. And it takes a really long time to play a 64 box game. But I spent a lot of my undergraduate life playing dots in class. All right, and then the restart button just goes back to the beginning. Zog is a generic name for an alien, and it was topical to something that came up last night in violin rehearsal. So.
Also, what happened at the end there, where you like you clicked one line and it gave you 3 boxes?
So.
Is that like a game rule or something?
So for example, it's my turn right now. If I complete this line, it's going to give me 2 boxes. It's going to give me this box and this box because I've completed 2 boxes now. Right? So by drawing this vertical line right here, 2 boxes are now complete. So I get both of those boxes. And it's still my turn, so I could grab this box. And I get that one, and it's still my turn, so I can grab this box. And I get that one, and it's still my turn. So I just had a really good run.
On my screen, it was like you clicked on you clicked and made a line between that got you 2 boxes.
Mm-hmm.
Also, automatically gave you another box.
Okay.
Left or something. But
Okay.
I don't know.
What would happen if you have all the boxes filled?
Once all the boxes are filled, the game is over. And then it should say, you know, game over, winner is, and tell you who won the game.
So can you tell me like what would define a complete box mathematical wise?
All 4 sides are drawn.
So basically each little box has its like own little variable. Well, not variable, because you said not to use them as different variables.
Yeah, so let's look at this. So suggestions, right? So there's a lot of ways you can do this, and I'm not going to require anything other than the indicated behavior and the fact that this is code you write on your own, right? So you can find code for this online, but it's got to be your own code. But how you decide to implement this is completely up to you. So I'm not going to require any particular classes except the main class should be PA3 or PA4. But I'll give you some suggestions, and this is a way that I wrote this sample code, and it makes sense to me. I think it's a fairly straightforward way to do it compared to what some other approaches might feel like. So take this as suggestion. Maybe it can give you some ideas. Maybe you'll do something totally different, but this might still help you in thinking of how you want to go about implementing this. So one thing to keep in mind, this is event-driven code, right? We're not going to have a loop that waits for the person to click a mouse button and then does something, right? Mostly our code's going to be asleep, but we're going to set up these listeners that say, hey, when the mouse button gets clicked, run this code. And in that code, we'll be able to see where did the mouse get clicked, and we'll say, oh, okay, so mouse click occurred right here. And so that means the person's trying to draw this line, and this line is not drawn, so let's go ahead and draw it. And that did not complete a box. So the next turn is going to be the other player's turn. And that's it. We're going to go back to sleep. And the next time a mouse click occurs, right, let's say our board looks like this. Let's say a click occurs right here. Now the game's going to say, okay, this was the XY. That should be this line that gets drawn. This box is completed. It's player 2's turn, so we'll put their initial in the box. It's still player 2's turn. Good night. And it'll go back to sleep. Right? So event-driven code, which we started talking about, that's the name of the game here. Right? Mostly nothing happens until a mouse click occurs. So we don't wait for the person to make a move, right? We update some variables to say, hey, the next time there's a mouse click, that's player 2's move. And then when the click occurs, the system can look and say, whose turn is it? Oh, it's player 2's. Okay, this is player 2's line. And then if a box gets completed, it puts player 2's initial in the box, and so on and so forth. All right, so event-driven code. We're going to talk about painting. We may get to painting today. If not, we'll do it on Monday. But painting in these kinds of systems is tricky. We can't just say draw a line on the screen. The reason is if you could write code that simply said, hey, I want to draw a line on the screen, your screen would be a mess. Because, you know, everything that's happening on our computer is trying to update the display. Right? The time changes by 1 second. The digit of my seconds on my clock changes. I move my cursor, and the location of my red arrow moves. And so some pixels that were red are turning white, and some that were white are turning red. And my pencil rolls, and now, you know, some pixels should turn yellow. All of these attempts to update the display, the graphical display, have to be coordinated. And so in Swing, we never get to just say, let's draw a line on the screen, right? What we get to do is we get to say, hey, when you're ready to repaint the screen, here's what I'd like you to do. So that'll be a whole separate topic. We might get to it before the end of today, otherwise Monday.
In other words,
Mm-hmm.
so basically you're just kind of redrawing the entire. It's kind of weird. You're redrawing the entire board, is what you're saying.
Exactly.
But that sounds like it's kind of the same idea as you're mentioning about having to resave the entire file. Kind of like PS3,
Yeah.
where you're running the entire file.
Yep.
Which is, again, I'm not a fan of, but if that's the easiest way, I'll do it.
Yeah, no, exactly the same idea. And I feel what you're saying, right? When I was getting into some of this stuff, I had kind of an aversion to, you know, doing so much work just to light up one pixel on the display. Why should I redraw the entire display? And you kind of have to have faith that like the machine does not mind, and I like to feel like it doesn't mind, right? And things are fast enough. But in fact, you know, we know that the entire display is being redrawn 60 times a second nominally, maybe 90, right? This display is being refreshed over and over again, right? It has to, because, you know, that's how we make things move. And once every 60 seconds, that's, you know, an eternity to a computer. If you've got a 3 gigahertz machine, how many things can you do in a 60th of a second? It's a huge amount. So it ends up not being a very demanding business. All right, so ask questions, right? We'll go through this in class. Don't expect everything to make sense the first time we talk about it. We're going to talk about painting hopefully later this afternoon. May not make perfect sense, may not make any sense, right? But we're going to take these concepts, we're going to work with them, we're going to go over them multiple times, and they'll start to sink in. You want to be writing code, right? You want to be taking the things that we're talking about and using them in practice. So that when you're at the point where you're trying to draw lines for PA4, right, it's not the first time you've ever tried to make a line appear on your screen. You've done this with little pieces of code, you've reproduced some of the stuff we've done in class, and so on. So work on it in code and ask a lot of questions. Concentrate on one thing at a time, right? If you understand the pieces, then the challenge of PA4 is putting those pieces together, just like with PA2, right, or PA3. So plan to work on this a lot, right? As soon as PA3 is done, I would say start working on PA4. Maybe take a few hours off. And then starting on PA4, try to work on it frequently throughout the time, right? Don't leave it for a week and try to start it a week before it's due. It's going to be a really bad time. If you can only work on it, you know, a few minutes at a time, work on it a few minutes at a time. But get your brain, you know, at least engaged with these ideas, and try to get one thing working a day maybe, you know. And if you can find 30 minutes to work on it in between everything else that you've got going, that's going to help you a whole lot more than saying, oh, I'm going to wait, you know, 7 days and then work on it for 3.5 hours, right? So constant effort will probably pay off more than waiting and then trying to do one big push at the end. All right, so you're probably going to want a class named box, right? Which describes a single four-sided box, right? And your board can simply be a 2D array of boxes. So we can make arrays of objects. So make a class named box which represents, you know, one of these things. And then make an object called board, which is an 8x8 array of boxes.
So it's kind of like the tree idea, except you're creating an array.
Yeah, create an array. It's a lot simpler than a tree or a list.
So when it says to make a box class, I imagine it's like kind of describing the definition of a box, like the top line, left line, bottom line, so on.
Mm-hmm.
And all that's completed, like let's say all that's equal to 1, because 1 or 0, depending on like whether it's true or not.
Mm-hmm.
Then that means that the box, you can have like box is set equal to true. That's kind of the way I would think about it.
That's the way to do it. That's the way I was thinking about it.
Cool.
So I suggested using booleans for top, bottom, left, and right to tell me whether a line has been drawn. So 4 booleans per box. If all 4 of the initialize all of those to false, that means there's no lines drawn for this box yet. If all 4 of those booleans are true, so if top and bottom and left and right, the box has been drawn, which means somebody owns that box. Well, have another field in your box to store the initial of who owns it. So I could just have a character variable, and I could store the initial of the current owner of the box in that. And if nobody owns it, maybe it'll just be a space, or maybe it'll just be empty or something. All right, so modularizing is going to help a lot with this. So for example, to initialize gameplay, we need to initialize a bunch of stuff in the very beginning, and when you hit the restart button, you need to initialize all that stuff again. Make a method for that, right? No point in writing that code twice. Make a method to initialize. So how do we do that? Construct a two-dimensional array, 8 by 8 of boxes. Each of those boxes set the top, bottom, left, right to be null, right? That's basically going to initialize your gameplay. Oh yeah, and decide who's going first. So if player 1 is going first, have a flag, you know, for is it player 1's turn, or whose turn is it, 1 or 2, right, or something. Initialize that so that it's currently player 1's turn. Make a method to take an XY click and tell you if it's a legal move. So we're going to have, you know, a playing field. If each of these is 50 by 50, it's going to go from 0 to 399 and 0 to 399. And so if they click, you know, at 420, 15, you know, over here, that's not a legal move. If they click at some negative coordinate, that's not a legal move. If they click somewhere inside, you know, the game area, how do we know which line they're trying to claim? Well, we could write some code for that, and we can put that code in a method. And then if we know what line they're trying to draw, and we can figure out from that what box they're trying to draw a line on, we can check that box object's, in this case, top Boolean, and see if it's already true. If it is, it's an illegal move. If it's not, set that to true, right? And that records the fact that they claimed that line. And since we just updated a line in this box, now check to see if all 4 sides are true. And if they are, they've completed this box. So set the initial variable to, you know, whoever's turn it is, whatever their initial is. And somehow note this so that we don't change it to be the other player's turn. So you can split this up and modularize it however you like, but, you know, suggestions: make a method to check legality of a click, make a method to update the game board array based on that click, make a method to adjust whose turn it is, make a method for resetting all the attributes of the game, the initials, whose turn it is, and so on, right? If there's some task that sort of stands by itself, consider throwing it into its own method. And you can do this with just a few classes. Your main PA4 class, your box class, may be all that you need, other than, you know, all of the swing stuff. But for the actual gameplay, the boxes actually drive a lot of this. This is also a chance to think about moving from data-driven to process-driven. Now, what do I mean by that? Suppose you want to know what the current score of the game is. Well, you've got 2 ways you could do this, at least. One, you could initialize, you know, P1 score to 0. You could initialize P2 score to 0. And then as you're playing the game, if player 2 completes a box, you could say P2 score plus plus. And if player 1 completes a box, you could say P1 score plus plus. And the next time player 1 completes a score, P1 score plus plus, this will be a 2. And now if I want to know the score, hey, P1 score is this player's score, P2 score is player 2's score. That would be a very kind of C-style way to do this. But we don't need to do this at all. If we have access to the game board, what can we do? We can make a pair of for loops. For column equals 0 to 7, for row equals 0 to 7. If the initial in here is player 1's initial, increment player 1's score. If the initial is player 2's initial, increment player 2's score. At the end of our loops, we've calculated the scores for player 1 and player 2.
Can't see what you're drawing.
Okay, thanks. I didn't draw much. Right, so rather than keeping a pair of integers that we update continually every time that a box is completed, we can simply go to our game board, and count how many letters are owned by player 1, how many boxes are owned by player 2. That's how we can figure out the current score. We could have a Boolean flag called game over that we start off as false, and after we complete the last square we set it to true. Or game over could be a method. And what would that method do? Count the number of squares owned by anybody, and if it's equal to 64, the game is over. Return true. Otherwise, return false. So if I make a method called player1 score, and I make a method called player2 score, and I make a method called game over, I don't need these magic global variables anymore. And I don't need to keep track of these magic global variables, and I don't need to reset these magic global variables when the person hits the restart button, right? And when we move to a networked version, I don't need to share these global variables from one player to another. These can be methods that simply look at my array of boxes and calculate player 1 score or player 2 score, is the game over. And this is a really common theme with object-oriented systems. If you look in Android development, for example, you'll see lots of stuff that basically does this. So keep that in mind. Think about it. We'll talk about some more examples, but that's what this refers to down here. If you have an update score method, right? That any time that you think the score might have changed, just call update score. And what will that do? Well, it will go through your array of boxes, see how many boxes are owned by player 1, how many by player 2, and then change the display. Or maybe it'll just call these methods and take the return values and display those. Right? But now my only task is keeping this array of boxes up to date. If somebody claims this line right here and that completes a box and this becomes ends box, I don't have to update a score. I don't have to check to see if a game is over, right? I can just call these methods and they will notice, that there's another box here with an N in it and add that to this score. Or notice that, all the boxes now have initials and so the game is over. All right, so mouse clicks. We've gone through this a few ways so far. Basically, you're going to have something that listens for mouse clicks. So we'll add an event handler to whatever we're drawing our dots on. And when a mouse click occurs, we'll start executing some code. The code can get the XY coordinates of the mouse click, and you have to decide which line you're closest to and then act accordingly. And we'll talk about some algorithms for translating an XY into, which edge of which box does that click correspond to. So we'll go through some ideas for that. And again, when you complete one line, it may actually complete two boxes. So if I've just drawn this line here, right, because they clicked right here, well, I want to know if this box is complete. I've also got to check to see if this box is complete. So that's just something to add in. And then the main business, which we're going to next, is drawing the board, right? And again, we don't get to draw the board at will. We can't, in our mouse handling code, say draw a line, right? What we basically do is we set things up so that when the board gets drawn, it looks correct. So how will the board actually get drawn? We've got a 2D array of boxes. Just go through element by element. Go to the first box. Figure out the XY coordinates for each of these corners. And now if this thing's top flag is true, draw a line between the upper left and the upper right corners. If this thing's left flag is true, draw a line between the upper left and the lower left. And the same thing for the bottom and the right. And now go into your second box and do the same thing. You might draw this line twice, don't worry about it. Just figure out the coordinates for the four corners of this box And if the top is true, draw a line there. If the left is true, draw a line there, and so on. So if you had a method that would draw the appropriate lines for a given box, right, then we just have a pair of for loops for column equals 0 to 7, for row equals 0 to 7, draw box, row, comma, column. And in that draw box method, what do? Well, we figure out the coordinates for each of these corners, and then we check each of these booleans. Well, how do we figure out the corners? Maybe we make some methods. Find upper left corner, find upper right corner, and so on. How do we draw the line? Well, that's something that Swing will give to us, actually the Abstract Windowing Toolkit. So we'll use something called draw line. And if the box belongs to someone, well, if left and right and top and bottom, then we want to draw an initial in the middle of the box. Well, there's another method called drawString. And we can give it an initial as a string, and it will draw that initial in the middle of the box. All right, and so be methodical. Think about this a little bit before you start coding. Be prepared to go back and you know, change direction sometimes. Start down this way, and you might get partway through and say, you know what, I've been thinking about the board. I should really be thinking about boxes. You might have to back up, go off in a different direction, right? Brainstorm with your group members if you're working in a group. Good coding habits. If you're sharing code with other people, it's a really good time to make sure that your code is, you know, indented consistently, that you're putting comments on your code. If you're creating a method, you're putting a little block of comments in the top that say, what does this method do? What are the inputs? What are the outputs? What are the side effects? So when your teammate tries to use that method, they don't have to go through your code and figure out what the code does. They can just look at the description in the top and understand it. Right? Good variable names will be really, really critical here. Score of player 1. Well, that's player 1's score, right? Don't call it S1 and S2 or A and B. Call it score of player 1 or score of player 2, right? This is a different mindset from kind of quick and dirty coding, where we use, you know, one-letter variable names. Think of this as you know, a novel that you're writing, as opposed to, you know, a limerick on the back of a piece of paper, right? It's something that's going to be grandiose and beautiful and enjoyed by millions of people for 100 years, right? And so with that kind of mindset, taking the time to write score of player 1 equals, you know, score of player 1 plus 1 is a little more palatable, maybe. All right. Grading, you can read the group rubric for grading. Basically, if I can download and compile your program, it's 15 points. If it at least starts by drawing a field and showing the initial score and such, that's another 15. If I can put in my names and it uses my initials, that's 5 points. If it responds to mouse clicks in some way, right, that's 15 points. So just having some kind of mouse listener is worth a bunch of points. If it actually draws the lines between dots based on where I click, so it does the right response to mouse clicks, that's 20 points. If it manages illegal moves, that's 5 points. So if I click outside the game field, if I try to claim a line that's already claimed, it should call me out on that and make me move again. That's worth 5 points. Adding initials to completed boxes, 10. Tracking whose turn it is, 5. Updating the score correctly, 5. And a working restart button, another 5. Submission, your main class is called dots. Sorry, not PA4, but dots. Does that contradict anything I said in the beginning? Nope. Okay. So your main class is dots, not PA4. So this is different from the other assignments. And I want to be able to run your code just by saying Java space dots. So your code may be broken into, you know, a dots.java, a main panel.java, a box.java, a bunch of different versions. You compile those, you might get a bunch of class files, right? You should just be able to say java dots and have it go ahead and run your program. So if you're getting into anything funky with weird window managers, with packages, with things like that, make absolutely certain that when I untar your file, compile all your .java files and say java dots, it's going to run, right? And that means you want to be using Windows 11. You don't want to be using other packages that aren't part of standard Java or aren't importable through standard Java, and so on and so forth. You can try running
11, you mean Java 11 or
Java 11, yeah.
okay? I was about to say if I have to download Windows 11,
No. Sorry. Yeah, so if you don't have a Linux system, you don't have a Dropbox, you can try running this on the server. And if it starts, it will give you a message like this. That tells you at least that it's compiled correctly and it's starting to run. But you can also open an SSH xtunnel by saying SSH-X if you're coming from a machine with SSH, or sometimes PuTTY has an option for it. But you know, you should have access to a Linux environment so you can test this as a standalone Linux program. All right, so lots of details we need to go through, but that's kind of a first order pass through assignment 4. Any other questions on that?
you said a 2D array of boxes, right?
Mm-hmm.
Not like an array of arrays, just arrays, or one or an array of boxes.
Oh, so box, board. Right, that should be a fine declaration and constructor.
Okay, so
So, maybe it's not technically a 2D array, but like in C, we don't even have arrays. I mean, they're just pointers, so it's an array of pointers. But this is typically what I mean by a 2D array. So we can say, you know, board, bracket row, bracket column, and that's going to be a box.
okay, yeah, okay.
Yeah. All right, let's play with some swing. Let's talk about painting. And this is a bigger topic for sure, but we can get started on it. All right. There we go. It's the appropriately named Java 2022-033333. So, I made note of where that last installation of Eclipse was, so I don't have to reinstall it. Alright, so here's our Java window. And by the way, I went ahead and installed VWrapper, so I have VI editing functionality in here. If you're interested in that, go ahead and Google VWrapper, And so it comes from SourceForge. And click through on the stable link, and you'll see a link here. Copy that, and then go into help install new software. And on this drop-down box, put in that VWrapper tag, and then search for VWrapper, and you should be able to select this and go ahead and install it. And that will give you a VWrapper button that you can turn on or off to enable or disable VI editing inside this window. So, personal taste. All right, let's talk about some painting. So I'm going to start a new Java project, and I'll call this Painter. And I'm getting the syncing feeling. This is not the installation I thought it was. Java 11, that's good. We'll go ahead and do that. Alright, so I'm going to make a JFrame, because every time I do a GUI type project, I'm going to start with a JFrame. So I'll go to Other, I'll go to Window Builder, I'll go to Swing Designer, and I'll say New JFrame. And I'll just call this Main. And so this is where we left off with Swing before, right? We can run this and we get a window that pops up. If I go in the Design tab, I have my JFrame, but I also have another object that's being constructed, which is called Content Pane. Content Pane is what's called a JPanel, and this JPanel is this section in the middle here. So the JFrame is the whole shebang. The JPanel is just this lower part below the title bar. And so our basic setup is, you know, we've got a JFrame. We've got this thing inside, which is a JPanel. And I'm going to draw on this. Now, when you make your dots game, you're going to have, you know, not only an area for drawing your dots and lines, but you're going to have a start button, a restart button. You're going to have some text fields for typing in names, labels for scores, and so on. So I would have typically, you know, on this original JPanel, all these different buttons and labels and stuff. And then I would have another JPanel inside here, something smaller like 400 by 400, which would be my game board. But for today, I just want to play around in the next like 12 minutes with doing some stuff with this panel. And if you look at the documentation for a JPanel, it's got a few methods, but you know, as usual, it inherits a number of methods from the classes that it extends. And one of these methods is called paint. Right, so that's part of the component class. And paint is the method we're most interested in. So invoked by Swing to draw components, applications should not directly invoke paint, but should instead use the repaint method to schedule the component for redrawing. Alright, so paint is a method which is called by Swing, by the internal, you know, machinery of this system. It's passed an argument which is called a graphics object. And graphics is another class that includes all these exciting things like draw a line, draw oval, draw polygon, draw image, and so on. And we're not going to call paint, we're going to call repaint. And repaint is going to say, hey, please call paint for me, Swing. And when Swing gets around to it, Swing will call paint. Alright, so here's the basic setup, and this may seem kind of wonky at first. What I'm going to do is I'm going to change the paint method. So let's get rid of this panel. I'm going to change the paint method inside this panel, so that when paint is called, it displays what I want to display.
Again, if you're drawing, we can't see it.
Thank you. I'm going to change the paint method inside this panel so that when swing calls the paint method, it displays what I want to display. And so let's just make a filled rectangle. So there's a method in the graphics class called fill rectangle. Takes an X, Y, a width, and a height, and it draws, you know, a little filled in rectangle. And my whole goal for the next 10 minutes, I want to draw a rectangle on this panel. Alright, so here's what I'm going to do. I'm going to create a new class. So I'm going to say File, New Class. And I'm going to call this My Panel. And I'm going to say public class My Panel. And I'm going to say it extends JPanel. Alright, and JPanel is underlined because it does not know what a JPanel is, so I'm just going to click where it says Import JPanel, and that'll give me my import statement. So we're going to write our own version of the paint method. So if we look at paint, inside component, paint. Right? So paint is public void, takes an argument of type graphics. So I'm going to do a public void graphics G. I got to turn off my autocomplete features. And so, what do I want to do in here? I want to draw a filled rectangle. So I'm going to say G, which is the name of the graphics object, dot fill rectangle, and we'll go 10, 10, 50, 80. All right, it imported graphics for me. It imported my JPanel for me. So this is a new version of a JPanel, right? It's called a My Panel. It extends a JPanel, which means it's got all the stuff inside a JPanel. But the paint method says, hey, let's draw a filled rectangle in the middle of this panel. All right. Well, over here, I've got a JPanel sitting here in the middle. And I can come back here and I can say content pane equals new JPanel. Well, I'm just going to change this and say content pane equals new My Panel. Right? Why not? So now that middle part of the window, this piece right here, instead of being a JPanel from Swing, is going to be a My Panel. And what is a My Panel? Well, it's exactly like a JPanel, but when the paint method is called, it draws a rectangle. So let's go ahead and run this. And there's our rectangle. All right. So let's make this a 10 by 10. So that's a nice small rectangle. So let's do something else quick and dirty. Let's go back to our design window. And I'm going to right click in my JPanel, my Panel. And I'm going to say let's add an event handler. And let's do a mouse motion, mouse moved. So now every time that the mouse moves inside my window, I'm going to get this mouse moved event. And what I want to do is draw my rectangle at the current mouse location. Well, I can't call fill rectangle from here. I can call fill rectangle from my paint method, but I can't do it from inside my mouse listener. So here's what I'm going to do. I'm going to say my panel save x e.get x, and my panel dot save y e.get y. All right, and I got to move some things around here. I said content pane equal to new my panel. I'm going to say my panel equals content pane, and I'm going to make my panel a variable up here in the top. Alright, so what have I got? I've got an object of type my panel, called my panel lowercase, which I set up here, and when I construct my new my panel, I'm going to set my panel equal to that. What doesn't it like here? Content pane. Oh, I'm just going to make this easier. Alright, so when the mouse moves, I'm going to call this save x and save y method inside my panel. So let me fire these together in the next couple of minutes. So I'll have an integer x and a y, and I'll have a public save x and I'll do the fancy this dot x equals x. And this is a void method. Public void save y, integer y. Alright, so I've got a pair of setters, right? From my main method I can say get the current x coordinate of the mouse event and save that inside my panel. Get the current y coordinate, save that inside my panel. And in my panel, when I fill the rectangle, instead of putting it at 1010, I'm going to put it at x comma y. And the last thing I'm going to do is in my main method, after I save these x and y locations, I'm going to call the repaint method in my panel. I am so out of time. Alright, we'll run through this more carefully on Monday, but let's see what this does. I'm going to go ahead and run this. I've got my frame. When I move my mouse around, I'm drawing a rectangle wherever my mouse happens to be. So we've got an Etch-a-Sketch program, and it took us about 10 minutes, but we got there. This is not the best way to do this. We're actually doing something that we should not be doing, but it makes for kind of a reasonable looking demo. But
Is it the override?
no, what we're not doing is we're not calling super.paint. And we're getting this persistence of the rectangles because we're not erasing the display every time that we repaint. But we'll talk about that on Monday. But it's a fun little demo for starters. So anyway, that was fast and hurried at the end. But but we got something to do something. So that was the initial goal for now. So we'll take this apart on Monday and look at these pieces more carefully and add some more information as to what's going on here. But this will be what we build on top of to actually do the painting that we need to do for PA4 to make the lines and the initials appear on the board and the dots. All right, cool. We're way out of time. Thanks for sticking around. Have a good afternoon. I will see everybody in office tomorrow, or I will see you next week. All right, thanks.
Do you have time for a question?
Yeah.
So what I did was I did what you said about saying my temp variables, but for some reason it didn't update the tree. So is there anything I need to do extra after I set the previous temp to the right nodes?
So when you get down to the bottom of, when you get to the end, let me go back to my stock camera. Let me see. I remember the picture, I don't know where it is. Anyway, when you get down to the bottom of the tree and you've got your new nodes, so there's your previous.
You're not screen sharing.
Yeah. Where is my screen share? Oh, my Zoom disappeared. Hold on a sec.
I'm always saying here, just go
Ah, there it is.
for two. So.
All right, there we go. So when you get down to the bottom,